We're going to do several worked problems where you're going to be drawing disaccharides. So we'll start with drawing a beta disaccharide of galactose and mannose with an alpha 1 to 4 bond. So in reading this, when we see galactose corresponding with carbon 1, that means that galactose is contributing its anomeric carbon. So let's first draw galactose. And we know that galactose is the C4 epimer of glucose. So go ahead and basically glucose would have hydroxyl at carbon 2 pointing down, 3 pointing up, and normally 4 would be pointing down for glucose, but since this is galactose, carbon 4 is pointing up, and then there's carbon 6. And then we want an alpha glycosidic bond, so that means that the anomeric carbon at galactose is going to have its oxygen coming down. And then next we need to draw mannose, and mannose has its carbon 4 pointing down because it's the C2 epimer of glucose. So it's going to, there's carbon 4 right there pointing down. The C2 epimer is just going to have its hydroxyl pointing up. And the other thing last thing we need to do is that the fact that this is a beta disaccharide indicates the stereochemistry on mannose, because mannose has a free anomeric carbon. So we expect its hydroxyl to be pointing up. So that would be our galactose alpha 1,4 mannose in a beta disaccharide. So the next question asks us to make an alpha disaccharide of galactose beta 1,4 mannose. So we're going to start off, let's draw galactose again. So carbon 2 is pointing down, carbon 3 up, carbon 4 is up. So now we want to make a beta glycosidic bond, so therefore that oxygen has to go up, and it's going to carbon 4 of mannose. Well, mannose has its carbon 4 oriented down, so and then mannose is the C2 epimer of glucose, so C2 will be pointing up, C3 will be pointing up, and finally we're asked to make an alpha disaccharide in this case, so the hydroxyl group is going to be pointing down. So that would be galactose beta 1,4 mannose in an alpha disaccharide. So this one asks us to make an alpha disaccharide of galactose beta 1,6 mannose. So this is going to carbon 6 of mannose. So let's go ahead and draw mannose first. So we've got hydroxyl at carbons 2 and 3 pointing up, hydroxyl at carbon 4 pointing down. Also, we're asked for an alpha disaccharide, so let's go ahead and put the hydroxyl, the free hydroxyl on mannose pointing down. And then basically here's carbon 6, and the oxygen that's attached there is going to be connected by a beta glycosidic bond to galactose. So that means that it's going to be pointing, the anomeric carbon on galactose is going to be pointing up. So galactose is the C4 epimer of glucose, so hydroxyl on carbon 2 down, hydroxyl on carbon 3 up, hydroxyl on carbon 4 is also up, and then carbon 6 would look like that. So, but basically we've got a beta glycosidic bond, and it's going between carbon 1 and carbon 6 of mannose, and then we have our alpha connection over there. The last one, we want to make a beta disaccharide of fructose with a beta For the last one, we want to make a beta disaccharide of fructose in a beta 2 to 6 glycosidic bond with mannose. So first of all, let's figure out how to draw fructose. So normally we think of glucose as having this structure, and the anomeric carbon can be either direction. But what we're told is that fructose is the ketose isomer of glucose. So we need to make fructose, and generally it's going to form, instead of forming a pyranose, it would form a furanose. And so this is carbon 3 right here. Well, carbon 3 on glucose has its hydroxyl pointing up. So we'll put that hydroxyl up. Carbon 4 will have its hydroxyl down. And then there's carbon 6. And then depending on, let's go ahead and do the beta form of fructose. So we would have its hydroxyl up, and carbon 1 would be down here. So now let's go ahead and put fructose together with mannose, making the beta 2 to 6 isomer, or beta 2 to 6 bond. So go ahead and draw our fructose. And we want a beta orientation, so that oxygen is going to be up there. And then this is going to go to carbon 6 of mannose. So there would be carbon 6 of our mannose. There's carbon 5 and its oxygen. And we know that mannose is the C2 epimer of glucose. So we'll have that hydroxyl up, and that hydroxyl up. Hydroxyl and carbon 4 will be down. And we want to make a beta disaccharide, so that hydroxyl will be pointing up.